Hi, my name is Manish Gupta, and in this video, I'm going to talk about LLaVA-OneVision, which performs easy visual task transfer. And basically, they show how one single model can actually perform really well across single images, multiple image kind of tasks, and video kind of tasks. Okay, so let's get started. What is the architecture of LLaVA-OneVision? LLaVA-OneVision is sort of a part of this LLaVA family of models. It's in fact a family of open, large multimodal models. Okay, so there are different sizes of LLaVA-OneVision model. I'll talk about those sizes later, but on this slide, let me talk about the architecture of these models. The main goal is to be able to have a single model which can actually perform well for multiple kinds of these scenarios, single image scenarios, multi-image scenarios, and video scenarios. It shows, as we'll see later, it shows strong video understanding and cross scenario capabilities through task transfer from images to videos. The idea being that you train it for images, but it works well even for videos as well. As has been shown by previous models also, it's just that LLaVA-OneVision is one of the latest models and performs really well. Okay. So now if you have a single image, the way you would give this image as input to this LLaVA model is by using the standard LLaVA architecture. The standard LLaVA architecture basically says that, hey, you will have some sort of a vision encoder so as to encode the image. And then there is, of course, going to be a large language model so as to be able to generate text, let's say for image captioning kind of tasks, right? But then there's also going to be a projection layer, which is going to take these vision embeddings generated by the vision encoder, project them to the space and the size desired by the large language model. And that is how you have the visual tokens, and then you have the query language tokens, text tokens, and you generate the output language tokens, right? Language response. Okay. Now, in LLaVA-OneVision, the input can actually come from a single image, or it can come from multiple images or a video. So all you want is basically pretty good encoder, which can take image, multiple images, or a video and come up with reasonably good visual encoder, visual embeddings, right? So in LLaVA-OneVision model, specifically, they make this choice of the visual encoder, the projection, and the large language model. So they use SIGLIP as the model for visual encoding, two-layer MLP as the projection layer, and the Qwen2 large language model. Okay. Now, to be able to come up with tokens or representations for images, they basically split the image such that you end up with A cross B crops, A being the height and B being the width, right? And then you represent each of those crops, each of those tiles. So you basically take the original image, you split it. In this case, in the image is a document, you split the image into multiple A cross B crops, so A being the height and B being the width, and then you encode them. So each of them you basically encode using T tokens. So for each crop, you essentially end up with T tokens. If the number of tokens, so basically, therefore, that gives you overall A into B plus 1 into T tokens, A into B because of these things. Well, sorry, so A and B are not height and width. A and B are like A equal to 4 here and B equal to 3. A is the number of, number of, number of things that can fit on the height, and B is the number of things that can fit on the width. So basically, there are like 12 different crops here. And for each of them, you end up, if you represent using T tokens, you end up with AB plus 1, the plus 1 for the original image itself. Okay. So that's the number of tokens. Now, these number of tokens may be too many for the LLM, and therefore you could do bilinear interpolation so as to reduce the number of tokens to some smaller value. And then finally, you flatten it and give it to the large language model. Okay. For single image, the LLaVA-OneVision model basically it fixes this n as 9. So essentially, it divides the entire image into 9 different equal sized parts. And therefore, it has 7290 tokens, where it uses 729 tokens per part. Okay. For multi-image kind of scenarios, let's say there are n images. For each of them, it basically takes 729 tokens. And so, for example, if there are 12 images in a multi-image scenario, you will end up with some 8,748 tokens. Similarly, for videos, they basically for sample n frames. In their case, typically they sample 32 frames and they use 196 tokens per frame, leading to about 6,000 tokens. So that's the number of tokens that we are looking at, a few thousands, something between 6,000 to 9,000 as visual input, right? Of course, there's going to be text input separately. So what data has been used to train this LLaVA-OneVision model? Well, I mean, they use high quality knowledge. They basically believe that the web scale public data set for images and text is basically pretty low quality, and therefore they gather synthetic data. Okay. In fact, 99.8% of their data is synthetic. And they gather this data from three different sources so as to have very good quality data set. Okay. So 3.5 million recaptioned detailed description data. What is this? So basically they took the captions from Coco, Blip, several data sets, and they basically asked this LLaVA next 34 billion models just to generate new captions for it. LLaVA next 34 billion model is a model in the LLaVA family, not the OneVision family, but they use their own family's models just to generate synthetic captions, and they use it, of course, to pre-train LLaVA-OneVision models. Okay. 1.1 million document OCR text to OCR data pairs. So this is basically from the text reading data set or the text reading subset from the UReader data set. And they do PDF rendering or rather this data set which is accessible through PDF rendering. They use this synthetic data also to pre-train the LLaVA-OneVision models. Lastly, to make sure that their models can understand Chinese, they specifically train on 92K Chinese and language data. So what they did was to basically take images from this Share GPT 4V dataset. So it turns out just like Share GPT, there is a Share GPT 4V dataset as well, which they essentially take the images from there, and they use GPT 4V model, 4Vision models, just to generate Chinese captions for it. And these generated captions, basically synthetic captions, are also used to pre-train. So 98.8%, I mean, they also use some manual labeled data, which I have not mentioned here, right? So therefore, 98.8% data set is synthetic in that sense, but high quality, right? The next stage is to basically do instruction tuning, and they do visual instruction tuning using large amount of data. So 3.2 million single image data and 1.6 million OneVision data, which is a mixture of video, image, and multi-image data. So in fact, this 3.2 million single image data is comprised of crazy number of data sets that you see here. They contain data sets, general image text data sets, but also they contain data sets about infographics. So document, chart, screen. They contain datasets around math and reasoning, general OCR datasets, and finally language-specific datasets. There are just too many of those datasets for me to name, but if you're interested, you could look at them and look into the paper for more details. Right. So they basically also train on a 1.6 million OneVision mixture data, which is a mixture of single images, multiple images, and video images and videos. Sorry, right? And I mean, again, there are too many data sets for me to name, but they have done a really good, rigorous job in terms of collecting all of these data sets and use them for rigorous instruction tuning of the LLaVA-OneVision model. So the training for the LLaVA-OneVision model actually is done in 3 steps: stage 1, stage 1.5, and stage 2. Stage 1 and 2 is basically what is pre-training. So they do language image alignment, high quality knowledge learning in stage 1 and 1.5. So in fact, in stage 1, they basically use something called as LCS dataset, but a small dataset. Stage 1.5, they use image dataset. And then in stage 2, they basically make use of this single image and OneVision dataset. Okay, so stage 2 is basically visual instruction tuning. So single image and OneVision dataset of the instruction tuning part, so as to essentially train the stage 2 model. Okay. So that's that. And yeah, I mean, in the first pre-training stages, only the projector is trained. But in the later stages, the full model is trained, right? Full model is trained. Overall, they train 3 different sizes of checkpoints: 0.8 billion checkpoint, 8 billion, and 73.2 billion checkpoints. So the largest model is 73.2 million model. I mean, well, they name it as 0.5 billion, 7 billion, and 72 billion models. Okay. So that is that. They don't do too many epochs. I mean, the data sets are themselves so large. They have like 3.5 million plus this, plus this, plus these, right? So the data sets are pretty large by themselves. And therefore, they just do 1 epoch each while training these models. What you see on the right side are the results on single image tasks. Of course, the results for other tasks are on the next slides, right? And these are results using LLaVA models, different size checkpoints compared with GPT-4V and GPT-4o. Okay. Now, you see, I mean, it's not obvious that the best model is really better compared to GPT-4V. everywhere. But in most cases, in many cases, you'll observe that it is better than GPT-4p or GPT-4, and comparable with GPT-4o. GPT-4o is really good in terms of image tasks. So it's not really as good, but LLaVA-OneVision is clearly better compared to GPT-4v in that sense across most tasks. Here are results on multi-image and vision tasks as well, and there are several of those tasks. You can look at them later and read about more details in the paper as well. But again, compared to GPT-4v and 4o, these LLaVA models, basically compared to 4v, they are better, but compared to 4o, they are slightly worse. So they're somewhere in between 4v and 4o. Okay. Here are some examples how LLaVA-OneVision performs. So basically, you can give it an infographic with two different things, some sort of a uh, sector from a pie chart, and you can also give this table. It can actually perform this joint understanding of diagram and chart from multi-images. So this is what they meant by transfer tasks. So although the model was never trained on two charts at the same time, but it can actually do this, what is called as easy visual task transfer and learn this emerging kind of a task itself of joint understanding, right? So where you basically give two infographics, the user also asks a question, and then the model can actually nicely come up with the right answer by doing appropriate math across both the charts. Okay, of course, pause the video to read up, what is being done there. Okay. Now, there are other kind of tasks that the model was not specifically trained for, but can actually do really well at test time. So for example, this one is multi-image GUI understanding, the GUI understanding for agents. So essentially what you see here are 4 sequential mobile UI screens. And, they are, of course, obtained by doing 3 steps of tap, tap, tap. And then the model is being asked to describe the 3 tap operations. And the model does a really good job in terms of telling what the first, second, third operation could have been, which led to these 4 different snapshots from the mobile screen. What you see on the right side is called set of mark prompting task. So you see there is an image and there are several marks like 15 and 1 and 11 and 12 and so on, right? And then the question that is being asked is please describe the objects that are marked as 4, 5, and 7. Okay, and the model does a really job of saying that, hey, 4 is a framed picture on the wall, as you see this guy is 4, right? And then 5 basically is a white bookshelf, and 7 is a black chair. Okay. Okay, so it can also do other kinds of things like image to video editing instructions. So essentially, the idea is that the user just provides this image and then tells the model, hey, please provide the video generation instruction that can change the source image to the target video. Okay. So the user actually provides the image and the target video. Some frames of the target video are shown here, but basically the user is asking for instruction that can be given to a stable diffusion kind of a model so as to be able to generate a video of that kind given the image. And you might not have noticed this, but let's see, here's a bunch of mushrooms and here is a bunch of penguins, right? And it's so interesting the way this morph can be done. But what is more interesting is the way LLaVA-OneVision model generates the prompt so as to be able to get this exact kind of a video generation, solicit this kind of a video generation from an interesting video generation model. Okay. You can also use LLaVA-OneVision for visual prompting in video. So basically, here is a video. 4 frames of this video are shown here, 1, 2, 3, 4. And the question that the user asks is describe the player highlighted in the video. There's a player which is highlighted. So describe what the player guy is trying to do. It basically says the player is wearing a white kit and number is 10 and so on. And what is the player trying to do? So it describes pretty nicely. Okay. There are more examples like referring image in video understanding. So there are 2 examples here. So for example, this is the image that the user provides, these 2 images, and the user says there are 2 images. Does the person in image 1 also appear in image 2? If yes, what is he doing? So the model basically says, yes, the person also appears, and the guy seems to be playing soccer with other individuals. Who is the man? So it knows it's Lionel Messi, right? And so basically it has this grounding as well. Of course, thanks to the huge and awesome pre-training, clearly it will understand Messi, right? And then it can also answer interesting question about Messi. What is he trying to do in this video? Okay. And yet another. So the entire dialogue can sort of also be supported, video-based or multi-image based dialogues using LLaVA-OneVision model. Right? Okay, so in summary, in this video, I talked about LLaVA-OneVision, which is basically an open large language, a large multimodal model that works for single image, multi-image, and video scenarios. It is trained using a large, clean synthetic data set and a large instruction tuning data set, so as to lead to strong capabilities. It shows strong visual understanding ability from image to video, and as the paper title says, it sort of also nicely transfers to multiple visual tasks like answering questions about multiple infographics or coming up with instructions to generate videos and so on. Okay, so that's it for this video. Hope you liked the video. Thanks for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.